welcome everyone to this private conversation with Dakota Semler, who is the founder and CEO of Xos Trucks. And those that have subscribed to us for many years now will probably remember Dakota as the CEO of Xos Trucks originally. But Xos have really, since the rebranding and the renaming, they've really gone into this hyper commercialization phase. And so this conversation will take place in two parts. One will be Dakota's presentation, which will give you a really good handle on what him and his team are doing. And then we will go into a conversation. As questions and ideas come up, put them in the Q&A box at the bottom. I know I'll have a lot anyway, as usual. And so I will leave this with Dakota to start the presentation, and we will just go from there. So Dakota, welcome to EV Fest. We very much appreciate your time here.
Thanks, Simon, and thanks to everybody else for joining. Really appreciate being here, and appreciate the opportunity to share a little bit more about Xos Trucks with you and how we got to where we are today. And hopefully we'll have a good conversation and dialogue in the Q&A about some of where the industry is headed and how we think Xos plays a role in that in the long term. So I'm going to go ahead and start presenting here. Great. So to give you a bit of background on Xos, I want to start really at the very top in the very beginning, prior to how we actually started and what myself and my co-founder were doing prior to founding Xos. So when we started Xos, we were actually fleet operators. We saw the challenges that diesel fleet operators face around the world, and that really prompted us to begin exploring how we could help solve a lot of the challenges that we were experiencing. This includes things like increasing emissions regulations, increasing complexity on the emission systems that were being designed and implemented to adhere to these emissions regulations, which increased our cost in operating the vehicles, but also decreased our actual uptime of those vehicles, requiring us to purchase a larger fleet. And lastly, the volatility in fuel pricing and how that impacted our overall profitability as a fleet business. Experiencing these challenges really led us to try and explore what technology solutions we could actually rely on to help make that transition and really avoid some of those engineering challenges that we were experiencing. So when we started Xos, we started with that fleet perspective coming from the background of a customer. And we're focused on really decarbonizing the commercial transportation sector through purpose-built technology that allows us to meet the needs of our fleet customers. That underpins everything we do here, from our engineering to our manufacturing strategy, to how we help customers install infrastructure and charging stations, as well as supporting the customers in the aftermarket. Operating a fleet is a very, very different reality than just driving a passenger car or owning a passenger car. And we wanted to make sure we provided the full suite of solutions for those fleet operators as they make that transition to a zero emissions future. So myself and Gio actually co-founded the business almost 5 years ago, and we wouldn't have been able to accomplish so much without an incredibly robust team. I'll start with our CTO, Rob Ferber, who is employee number 3 at Tesla and has really helped lay the groundwork for our energy and really our technology solutions here at Xos. He's been building battery systems from passenger cars to buses to light electric vehicles, and really is one of the leaders in the battery electric space when it comes to engineering complete lithium-ion battery systems. In addition to Rob, Dag and Adam also joined us from Tesla, where they led manufacturing and engineering portions of the organization and helped ramp up the Model S line in their Fremont facility. And to complement some of those leaders from the electric vehicle industry, we wanted to make sure that we were hiring from the traditional legacy manufacturers and understanding those customer requirements, the support and service requirements, as well as a lot of the technical and regulatory requirements that are so pertinent for on-highway vehicles. So folks like Jose Castaneda and Casey Evans joined us from Cummins and PACCAR, as well as one of our board observers, Mark Lampert, who's the former Senior Vice President of Sales and Marketing at Daimler. They're really helping to ensure that when we go to market and we deliver a truck, we're not just meeting the engineering and the technical requirements, but also all of the support and aftermarket service requirements that our customers come to expect. Now, I think everybody on this webinar is probably already familiar with the incredible tailwinds that the industry is seeing right now. But I just want to highlight one area that is incredibly important as fleets begin to make this transition to zero emissions vehicles. When you look at the transportation sector as a whole, although cars are a much larger population of vehicles, and there are significantly more of them on the road, trucks are actually a larger source of greenhouse gases. So as governments, as businesses, and as society at large begins to focus on transitioning to zero emissions vehicles, they're focusing on the areas that are going to have the most impact, and that's commercial vehicles. Here in the United States, trucks represent over 41% of the greenhouse gas emissions that come from the transportation sector. So every truck we put on the road has a more meaningful impact than the passenger cars that we're engineering today. And that's really important because it's not just the regulators that have taken notice, it's also the fleets themselves. Some of the largest logistics and parcel delivery companies in the world have made bold commitments and transitions to making that switch to zero emissions battery electric commercial vehicles. Now, I want to touch a little bit on technology because that's one of the areas we've focused on as we started the company, and it really differentiates us from the rest of our peers in this landscape as we've tried to understand exactly what our customers needed. So when we started almost 5 years ago, we began by actually building a Class 8 battery electric prototype. This truck was capable of pulling up to 80,000 pounds. And the first thing we went around and did with this vehicle was we actually drove it around the country and visited a number of different fleets, large parcel delivery companies, LTL, FTL fleets, and we asked them, in an electric truck, what could we build for them? What were the most important aspects about deploying electric vehicles within their fleet operations? And they came back really with two primary factors. The first and foremost was durability. They wanted a vehicle that was going to exceed their existing benchmark for their diesel vehicle fleet. They didn't want to make sacrifices on their vehicle reliability, and they wanted to ensure that it had the same level of uptime. The second most important factor to fleets as they make this transition to new technology is the total cost of ownership, or what we refer to as the TCO. This is a composite of three primary things: the acquisition price of the vehicle, the fueling cost of the vehicle, and the maintenance cost of the vehicle. When you take a composite of those things over the life of the vehicle, that's what's considered the total cost of ownership. So what you see here is our focus on TCO and how that pertains to the industry. Relative to our peers, we're priced at a discount. And that's because our focus in the technology and the areas of the vehicle that are going to be the most durability prone, but also the biggest cost centers in our vehicle is where we've focused. So that allows us to have a lower acquisition price than our electric vehicle peers, and a small premium to our diesel vehicle peers and legacy manufacturers. However, the savings from reduced fuel costs and reduced maintenance costs allow us to achieve a savings within the first 3 years on our medium-duty fleets vehicles and within the first year on our heavy-duty fleet vehicles. That's really important as we begin to make this transition and fleets adopt electric vehicles. They're willing to see this TCO savings in under 5 years, but they don't want to wait longer than that. So as the market evolves, you're going to see more folks continue to focus on engineering these battery systems in-house. We've been able to do that. We've been working on it for almost 4 years now. And that's really how we've been able to garner such leadership in the space and really attract so many of the industry's leading fleets. Now, the second point that I mentioned before that was going to be so important to fleets was the durability aspect. So as commercial fleet operators are evaluating any new technology, they want to make sure that it's going to be rigorous and it's going to meet the needs or meet the existing standard of what their diesel trucks operate on a day-to-day basis. As you probably are already aware, commercial fleet vehicles are used in an entirely different use case. In the event of a passenger car operating, it might run for 1 to 2 hours a day. It might do anywhere from 50 to 100 miles. It's a very light use case and also a very different use case. You're selling that vehicle on the merits of brand, on the merits of experience and performance. Whereas a commercial vehicle is really an economic solution. So all of our fleet operators want to be mindful of their total cost of ownership, and they want to make sure that it's going to last in the field. So the factors that are important to a passenger car operator or a consumer relative to a fleet operator are quite a bit different. On the passenger car platform, the two most important things are range and size. When it comes to commercial vehicles, weight, which impacts the overall payload of the vehicle, the durability and how this pack is going to last over the life of the vehicle, as well as ultimately the price, because that drives your total cost of ownership. So taking these requirements into consideration and getting that feedback directly from our fleet customers, we focused on engineering our own battery systems. So we start really from the cell level up. In our pack systems, we're using predominantly cylindrical cells today. And everything outside of that cylindrical cell is something that Xos has engineered, designed, validated, tested, and now we actually do the final assembly on. So we get that cell from a cell manufacturer, and then we go through that assembly process, building up our modules, building up our packs, and building up our vehicle systems before they're installed on a vehicle and ready to be deployed into the field. Why that's important is we control the entire engineering envelope. We're able to really ensure that these cylindrical cells are utilized in the most efficient fashion so that we can meet our warranty requirements, our customer durability requirements, the vibration, shock loading, thermal loading, and all of the other technical engineering requirements of the applications. When you look at our pack, it's not optimized for the passenger car landscape or for other electric vehicle applications, but we really have optimized it for the medium and heavy duty commercial vehicles of the world. And that's truly what differentiates us as you look at other systems out there in the landscape. I'll talk a little bit more about our manufacturing strategy. I touched on the fact that we are actually building our own pack systems in-house. This is our first facility in Tennessee where we're building the vehicles as well as our battery line. Smaller facility is where the battery is actually assembled. Today, that line is actually built in our facility in Los Angeles, where all of the process development from going from an actual cylindrical cell to a complete pack system is fully homologated and fully manufactured into a complete vehicle ready to be shipped to a customer. That's really important because we're not only controlling the engineering of the actual components and the parts, but also controlling the quality in the manufacturing process as these cells get assembled into complete vehicle systems. When you start to look at our pack systems, they look a little bit boxy, and that's actually deliberate by design. We've engineered the systems to have a high surface area to volume ratio so that we can insulate them against their ambient environment, ensuring that we're going to be building the most durable packs that are going to be able to operate in extreme heat climates or extreme cold climates. I touched a little bit on the manufacturing strategy. We're not alone in this. We actually develop a lot of the engineering, the process, the automation that goes into these facilities, but we also work with manufacturing partners. So Metalsa is one of those examples of a great partner of ours. They're a leading tier 1 supplier in structural systems and chassis systems for the commercial vehicle industry. And they've been an incredible part of ramping up our manufacturing facilities, as well as Fitzgerald, which is a leading manufacturer of commercial vehicles. They've also helped refine our vehicle manufacturing processes and have been a really incredibly large part of our ability to ramp volumes and meet the growing demand that exists in this market. So that's really the overview of Xos. As we dive in and Simon comes back on, really excited to be chatting with you today more about Xos's technology and addressing some of those questions you might have from the presentation.
Nice one. Thanks a lot, Dakota. And we're going to get Will Plunkett as well on to have this conversation. Will is one of our key sales guys, but it engages with the industry on a daily basis as well. And he has a lot of questions. He's one of those guys that just has a lot of questions which need to be answered. So Will, welcome to the webinar as well. Firstly, I want to dive into batteries because that's what I spend all my time really thinking about. And kind of how, I guess from day one, when you're thinking about this business and this whole concept, how do you approach batteries? And then as you commercialize and ramp up, does the way you think about it change? And the final part of this elongated question is both thinking of batteries in formats and in chemistry. So if you could tell us the story of batteries and Xos, that would be great.
Yeah, absolutely. So it really starts with the customer requirements. And I think you probably heard me say requirements 100 times during my presentation, but it's incredibly important when you're engineering any kind of complex technical system that you understand what the use case and what that end use case is expected to do in its final environment. And so that's why we had that voice of the customer when we first started the company. that gave us incredibly critical data around the durability of our pack systems that we were expected to engineer to. And so, UPS was actually a big portion of this, as well as a number of other fleets. We started to understand what all of the vibration, what all of the shock requirements are, what are the thermal loading environments, what are the warranty requirements, how do they expect these pack systems to degrade, and then what is the end of life plan or the second life plan for our pack systems. And that really helped formulate a high level requirements document, which kind of enabled us to explore which chemistries, which form factors would be the best and most suitable. I'd love to say I had more engineering expertise, and it was some epiphany that I had while I was sleeping. But the process was actually a really rigorous engineering process that we went through. Painful at times, where we actually had to evaluate, characterize cells, understand their aging behavior, and understand how they would perform in these environments. Because when you're engineering a passenger car pack, you're putting it through all kinds of similar tests. But what a lot of folks don't realize is the commercial vehicle standard is significantly higher. So if you're pulling a passenger car out and you look at a standard warranty on a passenger car, it's anywhere from 50 to 100,000 miles as a base warranty. When you look at a commercial vehicle, a powertrain warranty will regularly start at about 200,000 miles. So you're all of a sudden doubling that expected life expectancy of the system. So understanding those attributes was critically important to us, because that's how fleets are going to make their purchasing decisions. They want to make sure that it's apples to apples when they're comparing it against diesel or other technologies. So when we started scoping that requirement, we began evaluating an array of different kinds of cell types and form factors, and even chemistries, and trying to really understand how the math could work. And we ultimately landed at a cylindrical cell for, I think, a few different reasons. One is they have an incredible opportunity to be packaged into different flexible packaging options. So as you look at the landscape today of passenger car manufacturers, you'll notice that each of them have their own kind of methodology of cooling and packaging their cylindrical cells. And that gives you a degree of freedom and flexibility to be able to engineer it around your customer's chassis, the different wheelbases and layouts. And that is another aspect of it that really was factored into this. When you look at the commercial vehicle market, it's inherently more bespoke. There are a variety of different options. One customer might order one wheelbase, another customer might request another, different axles, different powertrains, different floor configurations or boxes. And so we had to have that envelope really well defined. And cylindricals actually afforded us a lot of that packaging flexibility while still being able to, achieve the degradation curves that we were anticipating.
Come back and finish that, but I think we've got you back, Dakota. Can you hear me?
Yeah, I can hear you.
Excellent. Is it my connection or Dakota's there, Will?
I think it's yours, because I didn't lose Dakota.
There we go. Sorry, Dakota. Finish. I missed the second part of your question, your answer. Apologies.
Yeah, no problem. It's really just trying to maintain that flexibility for the customer, but also engineering to the application that you're selling into. And I think that's incredibly important. When you look at this market, everybody thinks that all lithium-ion batteries are the same, but we really take an application-specific engineering approach. So a severe service vehicle that's used as a dump truck or a mixer truck might have a slightly different battery design than what you find in a parcel delivery vehicle or in a over-the-road tractor.
Excellent. So I'm just trying to get my connection.
I think
correct.
Simon's struggling slightly. I think my questions might be slightly less technical, perhaps, than Simon's, but I think whenever we sort of talk about electric vehicles taking over, it's very much a focus on passenger vehicles. That's kind of the starting block where it's known. And when we're talking about more commercial or fleet vehicles, that's often when hydrogen is kind of thrown into the mix. You've got more of a closed loop, longer distances. That's where people seem to see hydrogen fitting in. How do you see hydrogen, other technologies? Is it competition? Is it complementary? Is it irrelevant? What's your view on it?
Yeah, absolutely. So the market that we're going after today is really a market that already exists and that our technology is already capable of solving for. So when you look at the US commercial vehicle market, class 3, which is a 10,000 pound vehicle, all the way up to class 8, which is an 80,000 pound vehicle, there's about 13 to 15 million vehicles, depending upon the year and depending upon how you classify that population. Over 65% of those vehicles are operating on routes that are under 200 miles every single day. They return to base where they have dedicated charging infrastructure. What's important is that we're already building vehicles that solve that use case, that solve a majority of the market. So that's really the market we're going after. The remainder is what you'd consider your long haul vehicles or class 8 over the road trucks. And that's a segment that, while it's very interesting, it's one of the biggest segments in the commercial vehicle market. It is also challenging from a technology perspective right now and from a TCO perspective. So the focus of us has really been that vocational last mile delivery segment. And that's where we're centered on. You know, I can't speak to the efficacy of hydrogen specifically and the technologies and various companies that are involved, but I don't think in the markets that we're servicing, hydrogen is really a relevant competitor because you're paying for a lot of added complexity. All hydrogen vehicles are inherently battery electric vehicles as well with a small battery system. So you're paying for the fuel cell stacks, you're paying for the onboard energy storage, and then also the infrastructure. So in those short haul vocational routes or last mile delivery routes, it's been shown that battery electric vehicles already have a significantly lower TCO than hydrogen. So under 200 miles, the markets that we're serving, really we think battery electric vehicles are the long-term winner. They meet all the emissions requirements. They're the most affordable to operate. And they have, demonstrated durability that is on par with diesel. I think as you look to other longer haul markets, there's all kinds of technology. Hydrogen might be one of those technologies that plays a relevant role there. But I will say, as we look to this industry and how batteries are evolving rapidly, I think you guys are familiar with this, but cell manufacturers are seeing incremental improvements year to year. And while there are still some physical chemical limitations of lithium ion chemistries, there's been some pretty significant movement in the quality of the cells and the energy density of the cells over the last 10 years. And I expect as that continues to improve, as manufacturing is ramped up, not only will the cost come down, but the energy density and the performance of those cells will go up. So I would expect that 200-mile limitation on the vehicles that we're servicing to increase. But hard to say where that lands in this market, and particularly as it pertains to the long-haul trucks.
Okay, so when you're looking at new lithium-ion battery suppliers, you're testing new batteries for your variety of different products, trucks, and energy storage systems. How long does that process take, that qualification process, and is it changing, getting shorter over time?
Yeah, the answer as the CEO, it's never quick enough, but it is a long process. As you know, there are a number of different regulations that we have to make sure not only the cells pass, but the cells in their conceptual module architecture will pass. These include things like the UN shipping standards and UN 38.3. These include vehicle-specific standards like ECE standards and some of the EMI standards. So there's a number of different tests that we have to go through before we can qualify a cell supplier and process it to be able to bring it into production. I'd say some of the first tests start with characterizing that cell and making sure that the cell really behaves like it does in the data sheet. And there are a number of service providers and companies that are doing this out there in the industry that can accelerate some of this process. But we like to do it to really understand how that cell behaves. So we do a lot of that work internally so that we can run it under various different scenarios, really understand those aging curves, and understand how it's going to perform in a module system. So it is, I'd say, qualifying a new cell supplier with an existing form factor that we're producing is at least a year process. And, as we look to new form factors or new architectures, it's a multi-year process where you're really evaluating how robust is the supply chain, how robust is this particular cell or this part number from a specific supplier. And then you also, as any kind of manufacturing business, you have to also do a third-party audit or really understand where the supply chain of that cell manufacturer is coming from. Make sure, there's no conflict materials. Make sure there They have their own access to the commodities that go into that cell. So it is not a trivial process. I think we've learned a lot and gotten better over the years. But really, when it comes to a new form factor, it's a several-year process.
I'm going to jump in again. Simon and I are going to keep on tagging in and out.
Just actually, well, quickly, just before you do, I've got one question that popped in my mind. So when you're speaking to battery suppliers, you ask them about their raw materials and if they've got secure supply to make the batteries.
It's a question that comes up. And we are exploring right now what more robust third-party auditing for supply chain does. But for us, we want to understand that there is complete visibility. There are a lot of new manufacturers coming into the market. We want to have traceability to where those materials are coming from so that we can access them and so that we're not going to be constrained on our supply chain front, but also to understand and make sure that there are no inherent conflicts or problems with that supply chain.
Good to hear. I think that's what we and what a lot of our contacts in the industry are wanting to hear and want more to be doing. So great to hear. Again, my question is less on the battery technical side, but more on a geography focus, I guess, really. Being US based and US based yourself, not just a company, how important are other geographies, Europe or Asia? Are they secondary to sort of getting a real strong footing in the US, or are they priorities in their own rights?
Yeah, I would say that the market here in the US is incredibly strong and it's growing every single day. In addition to the current administration, there's a lot of tailwinds just coming from the private sector. A number of fleets have made some pretty bold commitments. Folks like UPS, FedEx, Amazon around their transition to zero emissions vehicles. So there's an incredible opportunity here. But I would just say that there are also opportunities abroad in other locations. Finally, I think folks have realized in the fleet sectors and as well as public regulators that we can't be going backwards when it comes to our emissions in the transportation sector. So we have actually a number of customers in Canada as well as in Mexico and in the North American market. And we have some interest coming from South American market as well as in Europe. And so those are opportunities we're constantly evaluating. For us and Xos as a company, we really want to go to a market when there's true customer interest. So we've built a flexible manufacturing model that allows us to go into a market with that customer interest. So we have some demonstrated interest from large fleets, and then we're able to ramp our manufacturing plans to meet those needs. Obviously, each market has its own homologation requirements and product specifications. So as we go into these new markets, we are building slightly different variations of our vehicle and our batteries powertrain systems, which takes time. But for us, I'd say the US market is our core focus. And then going beyond that, definitely South America and Europe are close seconds.
Got some questions on the Q&A that I'm going to start chipping away at.
Great.
Are you going to develop a dealer network or sell factory direct or a combination of the two models?
Yeah, so we actually believe in a hybrid model. So we work direct with a number of our customers in large markets where there's an incredible amount of interest in EVs and demand today. So if you think about the US, this includes locations along both of the coasts, West Coast and East Coast. And then when we look at some of the central states, the Midwest and Southeast, we're seeing a lot of interest from customers, but not as big of markets or end user markets. So we've actually already announced some relationships with dealers. We've really have a great partnership with one of the leading truck distributors in the country, which is a group called Lone Star, based out of Texas. And they have a strong relationship with some of the large national fleets like FedEx Ground through their base of operations in Memphis. And then in addition to Lone Star, we've also announced a relationship with Thompson Truck Centers, which is another leading dealership group in the Southeast to cover really the Tennessee region and a few other states in the Southeast. And we're going to be announcing some other partnerships in the near future as well around distribution and support. And I'll just add to that by saying these dealers are not just actually selling the trucks to their existing customers, they're also helping service and support it. So in market, instead of having Xos's own proprietary parts warehouses, we will work with those distributors to provide parts and service to those vehicles and those customers so that they make sure that we meet the same SLAs, the same service requirements that we would do for our customers along the coast. So it's really a hybrid model.
I'm going to jump back in if that's all right, Simon. I think there's a few bits of data and facts in your presentation, but I wasn't able to scribble stuff down, so I may have missed it, or it may not have been in there. But what's the sales pipeline like at present, and how quickly do you see that ramping up in terms of requests from customers and sort of, I mean, we're used to seeing the big steep curve of demand, but how do you see it from your perspective?
Yeah, absolutely. So 2021, we're planning on delivering 116 vehicles this year. That's fully contracted. Vehicles are actually in production. And 2022, we're planning on delivering just north of 2,000 vehicles. That's also contracted. And then 2023, we're planning on delivering about 8,000 vehicles. So there is a big ramp up in 2023. A portion of that is contracted through optional orders. So some of our customers that have existing vehicles that have the option to place more, basically reserve their build slots. And so that's where 2023 is. Pushing beyond that, fleets rarely tend to order beyond a 12 to 18 month business cycle. It gets too far out for them to understand where the macro and economy is going to be. And so they really tend to purchase on an annual, a biannual basis. So we don't expect to fulfill orders into 2024 or 2025 in the near future, but we really have some strong visibility into 2023's volumes and meeting those volumes and with our existing customer base, and then obviously with some of the newer dealership relationships that we're going to be announcing.
Yeah, excellent. And that's quite a big ramp up, as you say. Is that all from your current site at the moment, which is ramping up, or the plans to start operations in other geographies or elsewhere as well?
Yeah, so 2021 and 2022 will actually be coming from our facility in Tennessee, as well as our facility in Monterrey, Mexico, that we have with Metalsa. And that'll be the existing sites, which are both building trucks. When we look at beyond that, 2023, we will have another facility that we will also be bringing production from likely.
Dakota, on that 2023 number, can you give people an idea of how many gigawatt hours batteries, if you want to publicly, that is, but roughly how many batteries you're going to need 2023 and going forward, just so they put it into context with the industry at the moment, because it's getting a little bit crazy, really.
Yeah, I can't give you exact numbers because it obviously depends on the build configurations, but I can just say, 2023 is 8,000 vehicles expected to deliver. The vehicle, like the one you see behind me, this parcel delivery van, has a 120 kilowatt hour battery system. So that's a typical configuration. As we get into some of our heavier deliveries, like our chassis cabs and our class 7 and 8 vehicles, those can get up to 480 kilowatt hours. So you can kind of do the math and understand, there's a product mix in there. Not everything's going to be at the light end, not everything's going to be at the heavy end. And since this vehicle that we've had behind me is actually on the road operating with fleet customers today and has been for several years now, this is where a majority of that volume is going to come from over the next few years. But we do see an increasingly large opportunity in the heavier vehicles.
It's interesting, and that underlines just those numbers. Well, the 480 kilowatt hour battery pack. I mean it's logical now, but 3 years ago, people wouldn't be talking in those terms. They were barely talking in 40 or 50 kilowatt hour battery packs 3, 4, 5 years ago. And that underlines that you've got layers of demand from the vehicle industry. We haven't even talked about energy storage, which actually is going to be my next question, that is creeping up on people. That these numbers aren't going to be in those forecasting models for many businesses, right? And that's why the electrification trend, the energy storage trend, is going to continue and get stronger.
It's absolutely an important aspect, and I think one of the requirements that we've captured as a part of building our pack systems is the ability to design between multiple different suppliers. So today we've worked with suppliers like LG Chem and others, but we want to be able to actually work with multiple vendors so that if supply chains do become constrained, we can with cells that we've characterized, we can actually work with them to bring them into production and manufacturing should we see constraints in the near future.
Can you just talk briefly on your a bit more on the energy storage side of the business?
Yeah, it's a great question. So as we've dove into understanding the fleet customers' requirements, one of the biggest things that they've been faced with is how do they deploy infrastructure across multiple different locations for hundreds, or in some cases, thousands of vehicles. And so we've actually focused on developing really some services to help fleets with that transition. We call it our Fleet as a Service offering, or Exosphere. And really it enables fleets to make that transition to zero emissions vehicle without having all of the burden of figuring out charging infrastructure themselves. So we actually have really a full soup to nuts service that allows fleets to get a fixed fee for energy, where they can then work with Xos, where we handle the actual site engineering walks, the planning, the procurement of the equipment, the permitting and the installation, all the way through the site acceptance testing and the maintenance of that equipment after it's been tested. And that's really valuable for some of these larger and even some of the SMB fleets. You know, as we start to deploy vehicles in various sizes of customer fleets, they don't want to have to become an expert in electric infrastructure as well. So we've developed a structure by which we manage that all for those fleets, and they have a predictable energy cost so they can meet their TCO targets. When we've went out and started talking to customers about this became a very valuable tool. And we started with Loomis, which is one of our cash and transit customers. We're now handling all their charging infrastructure, and it's become a really interesting part of our business that's growing quite quickly along with our vehicle deliveries.
I'm going to jump topic again. I've picked out a question from Benchmark's friend Roger, who's big into his Formula One as well as all things electric. So I think this might be where this question's come from. And he's asking about the kinetic energy involved in slowing down a heavy vehicle. And obviously batteries, as we know, are generally quite heavy. Have you got any novel regeneration tech involved in the vehicles?
Yeah, so it's a great question. We develop all of our own software control layers. We don't build the hardware or the VCUs or the ECUs, but for the most part, we're controlling all of that regen, because that's going to have a big impact on how your batteries age, how they perform in the field, and ultimately the functionality and the usability of that vehicle in the field. So we do have some novel proprietary software of how we actually regen the vehicle and how we control that. It also varies across different vehicles because each of them have characteristically different drive cycles. So there are different methods of optimizing for different types of vehicles. For instance, a parcel delivery vehicle, like the one behind me, will operate, and it'll, in any environment with a UPS or a FedEx, it might make over 120 deliveries per day. So lots of stop and go driving, lots of low speed driving where they're driving under 25 miles an hour. That's quite a bit different than a beverage tractor or a beverage truck that's going to be making somewhere around 15 to 20 stops per day, or even less in some cases. But they're going to be spending proportionally more time on the highway or more time at highway speeds. So there's quite a few things that we're doing. When it comes to the battery chemistry, regen does impact it. But when you look at what the most rigorous drive profile is for battery systems, it comes down to really continuous loading. So continuous loading either up significant grades or continuous loading via high-powered charging. So that's really our edge case when it comes to engineering, designing those battery systems. Most regen loading, even if it's coming down a significant grade, there's still some pulse loading. So it's not as big of an impact to the degradation of those cells as you would find in a high-powered charging cycle, or a continuous high current or high C rate charge.
And sticking on the theme of chemistry, there's a lot of questions in the Q&A box about chemistries. Given everything that you've mentioned, I imagine there's lots of different chemistries for lots of different applications. Are you able to sort of give us an idea of what you see being the best match for different vehicles? Pardon me.
Yeah, predominantly what we're using today is versions of an NMC or an NCA chemistry. So the oxide class of lithium-ion batteries. We still think there are interesting utilization cases for lithium iron phosphates and for some other chemistries that are in wide production as well. We have remained, exclusively within the lithium category of batteries, while there are other, alternatives and some interesting technology being developed on the solid state front. Nothing that we have seen the energy density, the supply chain maturity, and the kind of form factor and technical requirements that we need to meet our applications. So for the foreseeable future, we're really anticipating staying within the, cobalt and NCM, NCA, and LFP chemistries.
Just quickly on LFP, you mentioned, is that a recent thing in your thinking, or did you consider that way back when you started?
Both.
Okay. Has it become more recent, or is it? I don't want to lead the question really, but has it always been consistent part of your process?
Yeah. So when you look at certain applications that need higher cycle lives, that are not as I guess range sensitive because of the gravimetric density, LFP becomes a decent alternative. I think a lot of folks have started to utilize it in the transit bus market, where the routes tend to follow the same exact route where there might be in-route charging. Most of the vehicles we're developing, you're developing a vehicle that has 200 miles of range, so you're not doing any in-route charging. You're doing it overnight, where the vehicle has dedicated charging infrastructure. So LFP does not present a real ideal use case, but there are lots of use cases where LFP might present a more interesting option, just given the increased cycle life, and also some of the characteristic features and the form factors that it's produced in.
I'm gonna be really simple in this the way I frame this question. You think of the van or the truck behind you there, it's a big box. Within that, you have the slightly smaller box, which is your battery component. Have you looked at, do you consider battery swapping? Is it feasible, perhaps more so within the truck industry than in the car industry, where it's almost part of the chassis?
Yeah, it's a question that we get asked quite a bit. And it was actually a feature that we developed for our initial prototype that we built when we started the company. We could remove the battery packs with a high lift pallet jack or a forklift. And as we began exploring that need, what we found is that a majority of the commercial vehicles on the road today in the US are operating on short haul return to base operations. So it's actual drive cycles where they're operating less than 200 miles per day. And so you really didn't need the added complexity of swappability. We also ran into the issue of how that asset is managed then, and how it's going to be treated across different fleet profiles. What is the complexity of the infrastructure that it requires to swap? And what we ultimately landed on is the economic use case and how we see this market evolving. We think it's actually more realistic to have dedicated batteries to dedicated trucks as the charging infrastructure becomes more widely available and more ubiquitous, and the cost of battery systems comes down, than optimizing for switching packs between different vehicles. It's not to say it doesn't work for some applications. Obviously, there's been some really good success in China with NIO and some of the other manufacturers out there. But for our applications and what our customers required, we felt that swapping was a lot of added cost and complexity for the use case.
What are your views on cell to vehicle, a more recent sort of trend in the EV space?
Cell to vehicle?
Yeah, so cutting out the middleman, if you like, and going straight into from the cell. I guess Tesla have demonstrated this recently in their recent bigger form factor. But any thoughts on that?
Yeah, I mean, I think there are optimization games you can play at every level. When you start to look into the market, I think you have to understand exactly how many units you're going to be producing. In a passenger car environment, you're producing an order of magnitude higher, and the cost sensitivity is lower. So you can kind of explore some more exotic solutions that may be better in the longer term. But it really becomes an optimization analysis of how much do you invest in tooling, how much do you invest in your actual own battery assembly line, as well as the combination of your cathode and your anode line, and how that factors into your overall business model. I think for Xos, weight is an incredibly important factor of any commercial vehicle battery system. And so, one of the things that we've thought of is how do the structures become more efficient overall, as a component of the battery system, and how can you make the rest of the non-cell components of that battery system weigh less. So we're exploring, different techniques there, and different materials to make sure we can achieve that. But the real fundamental requirements that we've always tried to adhere to, based upon our customer feedback, was cost and durability. And we cannot sacrifice those two things for other features or other kind of design characteristics that might be value added, but not necessarily the highest priority for right now in this market.
If I can, a quick question on sort of the charging infrastructure. I guess it's quite different to what we hear more about in perhaps the mainstream media with passenger vehicles, where you're looking for them on the side of the road. Would it be a case of a customer comes to you, they want to order X amount of trucks, you then have to order in or work out the charging infrastructure on their site, or is that something you do yourselves? Do you have partners for that?
So we have partners. We work with folks. We're not doing the actual construction, digging up trenches ourselves. We work with EPCs on a variety of different areas of the project. But we do all the program management, we do the equipment testing, evaluation, and then ultimately the actual infrastructure management afterwards. So making sure that fleets are not going to be charged demand charges, and optimizing those charge loads, and optimizing the vehicle utilization. So that's an area where we don't go at it all ourselves, but it's really a value add to those fleets to have that management tool once the infrastructure is installed, to make sure that they're going to get a guaranteed energy cost.
Excellent. Was that a hell of a lot to digest there, and we're kind of coming to the end of the conversation now. But before I close up and thank Dakota, what I want to say is, get in touch with Dakota. Firstly, you can email Emily Dunn. That Emily's been working really hard on sending all the invites out. You'll have her email, or you can email info@benchmarkminerals.com, or even Dakota. I don't know if there's a contact from your side as well.
Yeah, info@xostrucks.com, and it'll get routed to me or to whoever the most appropriate person is. Happy to answer any additional questions that may have come up during the conference.
Excellent. But Dakota is a true pioneer. I mean, these terms are used more and more regularly as the EV industry grows, but to build a company like Xos from scratch, to truly understand every single component of an electric vehicle, to build electric vehicles around a battery rather than just dump a battery into a pre-existing model. All of these things are, in Xos and with Dakota and his team, they're built from scratch. And I think that makes it, the company, the team, and Dakota very special. And I very much personally appreciate Dakota's time here today. So thank you very much, Dakota. Thank you so much for having me, both of you, and really appreciate your time and everybody else who joined today. It was a great conversation and some really, really great questions from the audience as well. Excellent. Nice one. Thanks a lot, Dakota. Stay safe. Thank you. You too. Bye-bye.